Good morning. All right, I didn't even say anything yet. I am Jake Wharton, and I am here to talk about how I got Compose UI running on a light switch. Let's go. So 14, 15 months ago, one of my friends sent me the Slack message. I have a new side project. I bought one of these. And one of these was a smart switch on Amazon. It's always about 50 bucks. Alexa, Google Home. And I'm like, okay, that's, generic smart switch. That's great. Why should I care? I've been trying to get my own app installed on it. Like, all right. Chinese servers, no Home Assistant support, whatever. Not really interested. Until he says, someone has discovered that it has an ADB server running with no password and root access. So getting into the device is simple. It's not AOSP, it's stripped down Linux, and it's been a fun project. And then I immediately was like, I just bought one. He discovered it through the Home Assistant forums, where basically some person bought it, wanted to get it connected to Home Assistant, did an Nmap, found the ADB port was open, and then was able to log in as root. And you can see him immediately replying down there. The switch is this. It's a Decora style, big display kind of thing. This is what comes in the box. Interestingly, it only works for US voltages, which adds some complexity to my setup up here that you'll see. It's got a bunch of watch or like clock faces. You can dim the light that it's attached to. It's got a bunch of detection stuff. So there's a light sensor where it can automatically turn on and off based on how much light is available. It has a really interesting feature where you can actually, if you have multiple of them, you can talk to other switches directly. So it's got a microphone and a speaker. You can broadcast all the switches that you have. It's pretty interesting. I was getting excited about it, and so 4 days later, mine arrived, and I snipped the end of an extension cord, Wagoed some clips to get it powered up, and tried to go figure out for myself as to whether the claims of it being root access were true. So connect to the switch, that works, and I do ADB shell, and I see this, and I'm like, this is probably the easiest root access in the history of hacking hardware. I am an amazing hacker. So we got root access on what is essentially a Linux box, but the box is very tiny. So how do we go from root access on a switch to what is this, the actual switch? And it's kind of hard to see. But I don't want to belabor my point, but there is a Compose UI app, there we go, running on the switch. I will show a much better version of this later. So it is I said the US-based power thing, it does not like the European power coming through my power converter. The light usually will blow people away, but yeah, not now. So how do we get to here? So, I was successful in pulling this off, but I don't know if you saw the date on when he posted this. It was January 3rd, 2023, so a long time ago. Immediately, I wanted to determine two things. Can I put the JVM on this device and basically just throw Compose UI Desktop on it? Because that would be great. And then how does the built-in app that runs on this work? So the very first thing I did was I went and I grabbed, Linux ARM JRE from your favorite JDK vendor, my favorite JDK vendor. The device only has about 150 megs of storage space. So we unzip it on my computer, push over the folder that gets unzipped, and then I write, everyone's favorite hello world in Java, only because I didn't want to deal with, pushing over the Kotlin standard library. Just trying to prove that the JVM works. go back, compile the Java on the host again, because it's just a JRE, that's just a Java runtime that I pushed over, no compiler. Push over my class file, and wait for it. Yeah, okay. And it works. So I run, my Java class path with my current folder, and I get hello. So the JVM works. And at this point, I'm like, this is still January 2023. I'm thinking it'll be a week tops. I'll have Compose UI running on this switch. Yeah, Kotlin Conf 2023. I'll be giving this talk. It's gonna be great. And then, so the other half was like, how does the built-in UI work, right? If I'm gonna take over rendering, how does it work? So we found a script. There's so much stuff on the switch, by the way. But we found the script that sort of started things up. The first thing it does is potentially start this thing called Westin, which is a part of Wayland, which is a Linux window compositor. It's responsible for putting Windows on a Linux desktop, essentially. But Westin is like for embedded Linux or even mobile, which kind of makes sense. Oh yeah, that's fun. So we didn't know as to whether or not that worked. There's a whole like sidetrack of like literally 4 months of me trying to get like Wayland and stuff working, not realizing that this if statement is never taken in on this device. But hey, you can actually run a desktop manager on the switch. And I have a little terminal that I was able to launch, and I built an app that displayed my image, which was very memeable. But yeah, this if statement is never taken, and like that's 30 seconds in my slides, 4 months of my life basically just gone trying to figure out how to do that, and it's not even used. The more important bits of this script are the actual launching of the the native UI. And so that's, it's checking to see whether it's already running and a bunch of other stuff, but this is like the important bit. Mixpad, GUI, passing some arguments, and so in that initial post, the person was like, I think it's a Flutter app. And so, I go and I'm like, okay, I search on the internet for Flutter and then like embedded and like Linux. And then the very first result is literally like Flutter embedded Linux GitHub repo. And I'm like, oh, this could be a thing. And it turns out that you go look in it and it's like that command line that I just showed, where it's passing -B and -C or whatever, that's in here. And I'm like, okay, that's a pretty strong sign that this is how it's getting set up. And then turns out that there's actually a log message that gets printed when the UI starts that I also found the associated print line or whatever the equivalent, it's all C code. And so high confidence, it basically definitively tells us that this is the repo that this company is using to set up the Flutter UI. And they're using a thing, it says DRM, which is not breaking your favorite DVD encryption. It's Linux Direct Rendering Manager, and that is how they are putting pixels on the screen. So that gives us our first taste of how we might do our own rendering. And then the very last thing was okay, if I just put Compose UI Desktop on the JVM, throw it on the device, maybe it works. Let's see how it doesn't work, and then we can kind of fix that. And it immediately is awful. It fails setting up skia. There's no GL, libgl, which is OpenGL, which skia was trying to initialize. And we're like, well, Flutter is also based on skia, so we know skia somehow runs on this device. And we found there's there's OpenGL ES, not regular OpenGL. And I am not a graphics programmer, so the distinction between the two is completely lost on me, other than the fact that they're different and of course require a bunch of different code. And then I start pulling on this thread more, and it's well, Compose UI relies on AWT, which is a Java thing that itself requires X11, which is a different window manager for Linux. And that absolutely does not exist on this device. Wayland barely worked, and X11 is non-existent. And so we kind of get this idea of like, all right, we'll start the JVM in headless mode, we'll initialize our OpenGL ES context or something, and then pass that to Compose Desktop. And I'm still confident. It's not, I'm gonna be done in a week, but I'll be done in a month. And of course, like the most obvious thing, this is a side project, right? I'm not being paid. The most obvious thing that happens to every project, which is absolutely nothing happens for literally 7 months. And then I finally get motivated to, the Kotlin Conf deadline is approaching, and I'm like, oh, I got 2 months till the deadline. I should probably, figure out how to do this. And so again, I go and I search for like Linux, DRM, like Hello World, simple example or whatever. I know absolutely nothing about standing up a graphics stack on Linux, but I find this C code, and I literally just toss it into GCC, push the binary over to the device, and like once again, I am an amazing hacker. I get the blue screen of life. I'm able to take over rendering on this like weird switch, and this again gives me the like high of accomplishing something and motivated again to continue to try and pull this off. But all that is like C code, right? And we're not at cconf, we're at Kotlin Conf. And so I'm like, well, I should probably try some Kotlin code. So we do the hello world, compile it in quiet mode because I don't feel like animating all of Gradle and Keynote. Push that over to the device, and very thankfully, this also correctly runs on the device. And so now I've proven that the JVM can run, and I've proven that Kotlin native compiled to Linux ARM can run. And so we've like a good idea of what we want to do. Maybe Kotlin native to set up OpenGL, and still thinking that I will, just hand it over to Compose Desktop and everything will be simple. But in order to port the C code, the DRM code, I have to like do some things because when I compiled the C code, it's actually using things from my computer to compile and then running on the switch, and I'm kind of getting lucky. But the way it actually works is like it looks at header files and generates like stubs essentially that you can call into, and then the SO, which is like the native binary, is linked into the either dynamically or statically linked into the final exe. And I was basically just getting lucky because on my my Mac or the Linux server that I was also using, it like has libdrm, which is what the switch itself has, and then my computer has the headers for DRM as well. So I would like cinterop was able to just do codegen or whatever, and that was compiling against the version on my Mac. But on the actual switch itself, there is a SO file for like the version of libdrm that it has. It says 2.4.0 there, but like the very last patch version they sort of omit, so it's 2.4. Some random version. But there are no header files on the device. And so if I don't actually target what's on the device, I'll reference functions that don't exist, and then it will just, it will either fail to link or it will straight up crash at runtime. So the way to work around this is like we can guess or do our best estimate of what's the version on the device. Unfortunately, 2.4 of libdrm started in 2008, and it is still the current version of libdrm. So there's a lot of potential candidates for what we can compile against. And the way that I have mostly solved this is by basically just running strings on the binary. And what that lets you do is just see every is essentially, it's the strings, right? It's the like human readable character sequences in the binary. And so what I do is I just go and I say, well, I'm going to look for an API that I know exists. So DRM mode get resources is like the very first API that the C code was calling. And like that is, so I'm counting the number of occurrences in the strings output, and like that exists. And so I basically did a like a binary search of the change log of libdrm to find when they added new APIs. And so in 2.4.98, they added the drm is master function, and I found that that actually does not exist on the device. And so I know that the version is older than 98. And so I just went back a couple months and grabbed, version 2.4.87 or something, and that would be good enough. It would prevent me from, calling into the wrong API. And then the critical thing is that that's the header that I've now downloaded that version, but I also need to pull that binary off the device so that I can compile against it. And so now, instead of my desktop computer being the one that provides libdrm, I'm getting the ones that will actually be used at runtime. And so, Kotlin is like implicitly going to be able to link against the things on your computer. And so, in order to tell it about these other things, I have to, set up a bunch of build stuff where I tell it about the header files, I tell it about the, path to this device/lib folder is like where the SO file lives, and then the -l_drm is basically telling it to link against libdrm. A lot of stuff to basically just say that now we have the ability to go and start porting over the C code. And so we go through, we start building, we're opening like the device driver to actually do rendering, and then we start referencing that DRM get resources, the very first call. Like I can now reference that in my Kotlin native code, and then we do the rest, paint the rest of the owl to get DRM working again. And I basically just spent, again, a couple weeks of my life, getting back to where I started. And then I have to repeat this process over and over again, where there's other headers and stuff that I have to pull to get the C code ported over. I pull a bunch of SO files. For some reason, I don't know why this thing is called Molly, but it's like OpenGLES and GDM and EGL, and graphics people love their acronyms. But I finally get to the point where I can get to the rendering loop, port it over, and I'm calling into OpenGL, and I'm excited. Get to compile that, push that over to the device. Everything's working great. I get a bunch of output. It's fantastic, and I'm just basically back where I started. Again, months of my life just going, and I've essentially just sort of moved laterally. But it was great because it essentially proved that Kotlin native, could stand up rendering on this device, and again, got me back motivated to try and finish this project. So this runs over and over again until you quit. And so the next thing was all right, I'm able to paint pixels, not very interestingly, into blue. How do I actually draw interesting things? And that leads us into a library called Skiko. Skiko, it's a library by JetBrains. It calls itself Kotlin multi-platform bindings to Skia. In actuality, it's Kotlin multi-platform bindings to Skia for Compose UI. So if you're doing something that's different than what Compose UI is doing, like on the desktop or on iOS, it's not going to help you. And so there is no Linux ARM availability here. I cannot just stand this up and use it for rendering, unfortunately. But in my naivete, I'm well, how hard can it be, right? There's Kotlin native for iOS and macOS. Surely Linux is not going to be that hard. Skia is a low-ish level graphics library from Google. Chrome built on Skia, Android's built on Skia, Flutter built on Skia. Rest in peace. It's absolutely everywhere. It runs everywhere. Multiple backends, so OpenGL, OpenGLES, all the GLX, which is another thing. I don't know all the acronyms, but it can basically run everywhere. JetBrains takes the Skia proper, and they build it for Skiko using this repository. which is actually awesome. It uses GitHub Actions to just do the build, which we'll see as that comes in handy. But they only build OpenGL, and they don't build EGL, which is like the thing that we need. Thankfully, well, first thing I did, of course, was file an issue, but trying to get this done, so I'm going to do it myself. Fork the project, literally a one-line change, just throw in a skia config, and then I wait for CI to build the binaries, which takes 2.5 hours. I'd like to pretend that I only had to do this once and that one-line change was the only thing I did, but again, the theme here, this was like weeks of my life waiting for GitHub Actions to build skia as I tried to figure out what the hell I was doing. But once we have that, we can go back to Skiko and try and get it integrated. Why am I going through the same slides again? 2.5 hours. Okay. Skiko. It is both Kotlin native and C++. Skia is a C++ library, and so Skiko has both C++ code that calls into Skia, and then it has Kotlin code for the JVM or Kotlin native that binds to their C++ code. And so this is the entry point for setting up rendering in Skiko. This is a public Kotlin thing. It calls into some other function, which is itself an external function. So it is bound to some crazy symbol name in C++. And then in the C++, it calls into skia. But this is for OpenGL, which I showed that we don't have. And so I basically, did my best Stack Overflow programmer and just copy pasted what was already there, changed it to EGL instead of GL, because that's the thing that I need. Created a new extension, external function, created my new entry point, and this all went very well. But then I had to compile it for Linux ARM, which was not a target it supported. So this was going fine. I add the target, I'm following the conventions. Normally, they download the skia dependency from their skia pack repo. I got lazy. I just checked it in to my fork because I didn't want to figure out how to make it download from my fork. Updated the download task to point to the checked in file. And then the last thing is how does it actually compile the C++ code to ARM? It normally calls out to Clang, which is a C compiler, and I had to change that to a different script because things started getting interesting. Basically, the build setup of Skiko only can compile for the host that you're running on. So if I'm on my Mac, Skiko can compile for the Mac targets. If I'm on my Linux x64 server, it can compile for Linux x64. And I'm like, okay, well, I need to compile for Linux ARM. Well, turns out that I tried to do this on a Raspberry Pi, which is an ARM Linux device. Kotlin itself will not run on Linux ARM. And so there's this chicken egg problem where I can't compile for Linux ARM. I can't compile for Linux ARM on my Intel, I'll just say Intel and ARM, my Intel Linux box. I have to compile on ARM, but Kotlin is not letting me. That's for the C++ code. But then the Kotlin native code refuses to compile because there's no toolchain built. So the reason that I created this Skiko Clang is because I, again, just did the laziest thing possible. It calls into Docker because I have a Docker container running on QEMU. I've never had to say this out loud. QEMU, right? I don't know. It's basically running an ARM emulation layer and then a Docker container inside the ARM emulation. Horrible stuff. But I go into, you start this container, it runs the version of Ubuntu that the GitHub Actions runs, and then I copy paste their Docker file setup. Lots of again, pain and suffering of my life for months, all to get to this, where I can just reference that function in my Kotlin code. But ultimately, it works after a lot of pain, and I can start calling into skia to set up rendering against EGL, which is the thing that the device uses. And that gives me a surface and a canvas, which are skia types. And if you're an Android developer, surface and canvas might seem familiar from the Android APIs. They are basically exactly the same APIs as skia. So I can do things like, draw red, I create a blue circle, and then I create a green line, and ship it over. And again, there's lots of hidden pain in the iteration process here, but ultimately, this works. And I now have skia in Kotlin native rendering to this display, and I pull off, my red background, blue circle, and also text works. This is one of the rare photos that's in the daytime, because usually I'm working on this late at night. All right. Just rendering is interesting, but if I can't touch it and interact with it, it's not really an interaction. It's not really like a good deployment, I would say, of an app. On Linux, there's this binary called evtest, which is short for event test, and it shows you all the input sources that you can use from the hardware you're running on. And so this is what the switch reports. There is a hardware button on it, and there's also the touchscreen. The hardware button comes through number 3, GPIO, but the number 1 there, event 1, FTS, TS, the TS I assume is touchscreen. I don't know, but you do number 1. It prints out a bunch of information about how it delivers the interaction on the touchscreen to you, essentially. And so we see that there's like these codes, like event code 330 is the touch event, and then down here there's like the position X and the position Y are 53 and 54. And so, and then it helpfully dumps you into this like interaction loop where it then reports these events. And so you can see, like, I touch the display and I can see like the events that come in. And this gives you an idea of like what kind of data you would be consuming if you interacted with this event API. And so I do the very simple thing. It's not multi-touch, so thankfully I only have to deal with basically the state of one pointer. Set up some, member variables, and then I just do giant nested when statements. If it's, this particular event, and if it's the position X, the position Y, we cache that in our local. If it's this like synthetic key event where it's basically I'm touching the screen or I'm letting go. So this is I'm basically we implicitly know that you're touching it when events start happening, but then you let go, we get this 0 value, and then this is the synthetic event that happens at the very end. So you sort of know that like this is when you can send or like do the processing that the touch event actually represents. And so we do some stuff to map it to some things and turn it into a data class or whatever. And this code sits in our render loop. So I can render things, I can parse the input of things. Now I want to put those two things together and actually draw with Compose UI. I said previously that like all of those steps, like I had to cut, I cannot convey how painful all those previous parts were. And I got to the Compose UI part, and I'm like, this is going to be awful. And it turns out this was like the easiest part of the whole thing. So fork JetBrains is I fork JetBrains' fork of the AOSP Compose, add a Linux target, and then it's just going through the expect actuals. So I start at the leafiest dependency and add in my actual, and then I just work my way up the dependency tree. So I get random UI dependencies, and then I finally get to the UI, Compose UI, add my target. I have to deal with things like they have information about input events, about keys, which is like for actual keyboard stuff, which I don't have. I only define 2 buttons. Well, I define 1 button. Interestingly, like Compose UI has to know about the main thread that the UI is running on, which actually, again, I cannot convey, but like weeks of my life were spent on a deadlock in this project because of this. So hopefully that will get fixed. More expect actuals. I'm moving up the stack. I'm now in Foundation, Compose Foundation, which is built on top of Compose UI. Dealing with stuff like what's the scrolling behavior, where they do, like in iOS, it does the over scroll or whatever. But in general, I'm just copying the actuals from like Compose Desktop. And then finally, I make my way up into Material. And again, I'm adding my target, and I finally get to the point where it all compiles. I've been holding this for like 5 minutes trying to take a drink. I finally get to the point where it all compiles, and then back in my project, I can reference the entry point to I don't want to say, it's JetBrains' Compose UI entry point. The Android entry point is different. If you're ever doing this, again, make sure you pass in coroutine context here, because again, weeks of my life spent on yet another deadlock. Inside my render loop, where I was previously doing the low-level skia calls through Skiko, I can get rid of all that and just call into Compose UI and say, here's the skia canvas, turn it into a Compose canvas. Here's the current time. And then the last thing is we were doing the input processing, feed that into, if I ever register an input event, pass that into Compose UI. And then we need something to render. So the very first thing I actually did was a text, and that crashed spectacularly for font loading reasons. And so I switched to an empty button, go over, I hit deploy, and lo and behold, the very first Compose UI rendering on the Switch, which is horribly ugly, but I was so excited. And so we set out at the beginning thinking that we would just like create the context and throw it to Compose Desktop and be lazy, because as a programmer I'm very lazy and want to reuse as much work as possible. But it turns out this wasn't actually that hard to get it compiling for Linux ARM. So again, rare desktop shot, daylight shot, made it a little nicer. I got to the point where I could touch it and I was getting ripples, which was amazing. That sort of felt like I had completed this journey. But I wasn't over the finish line yet, because ultimately it's still a Switch and I had forgotten that it needs to turn on the thing that it's connected to. The built-in UI talks to the hardware over a serial port using this protocol. I have not been able to reverse engineer it. It's like a binary protocol. I just haven't had the time. Thankfully, they ship this like server on the device that also talks to the hardware, but it itself exposes a Unix domain socket at some random path that you can send half plain text, half JSON commands to that will affect, that it will then translate into calls to the underlying controller that does dimming or whatever. And so the very last thing was like, you can speak Unix domain sockets with like built-in Linux APIs, but going back to the laziness, I just grabbed Ktor. It has Unix domain socket support, so we set up where I can write to this random path, read the response that comes back. And I'm actually showing some of the pain here. Of course, at the final step of this, it crashes with some random thing, and I have to go and yet again file a bug, fork a project, and make some change to make the thing lazy so that it actually works on this crazy weird device. But ultimately, that ended up working. And so the very last thing was How the hell do you present a light switch in a public context? And so I built this enclosure, which has a light socket in it, wired to the switch, extension cord coming out that plugs in. The light bulb stuff works. That is a ridiculously large Edison bulb that I screwed in. And then I also have a it's not plugged in now, but if afterwards, if you want to come find me, I have the original built-in UI next to my custom UI that you can see. And so here's a better shot of like the UI that we've built. It's basically just a draggable and touchable switch that will, trigger the relay. Huge props to the TSA for not pulling me out of line for packing crazy shit in my bags. And then, yeah, so I sort of already demoed it. It's hard to see, but the other nice thing is that guy, Eric, that started me on this project, he's a iOS developer, but he's amazing. He learned Compose UI, Kotlin multi-platform. He does like Wire, gRPC stuff. Like he learned all this and he built this like amazing interactive component for changing the light switch. And so you can, I don't know if you can see, but it's actually on, but it hates this nasty European power. It wants American. Thank you. Yeah. So over here, we basically built a desktop version. So in order to develop this, where'd that go? It was just up. It's a huge pain to develop this on and deploy to the actual, I'm gonna turn it off so it's not twitching in my face. So here's a better, representation where you can see the behavior of the switch. And then it's actually a pager. So I have fake settings. The settings don't actually work. Have not built that. And then this is my best take on a clock. But this is super helpful for the iteration process on the design. And it speaks to the power of Compose UI multi-platform is that, come on, you can get there. That I can run this, the same code essentially on the desktop as I'm running on the device. So all of this, I forgot to make the actual repo public. Maybe we'll just do that live. These are all my forks and the branches, all the changes I had to make. The KTOR one, they're like the KTOR maintainer immediately was like, yeah, we'll fix this and made a PR, but it hasn't landed yet. So that one will disappear soon. Hopefully the Skiko and Skia pack ones will disappear and they'll add EGL support with that issue I filed. I would not expect Compose UI itself to support Linux out of the box. It really needs you kind of need like an intrinsic window manager to run Compose UI. So like on Android, you have the view system or the windows and that stuff. On desktop, it's like the JVM and AWT. On iOS, you have UIKit and like the NSView and all that stuff on Macs as well. And there's just like for Linux, there's just nothing because it could be X11, it could be Wayland, it could be nothing. We're just basically directly rendering. So I wouldn't expect like anyone to support this out of the box. And then the one thing I want to show, just for fun, if I can find it, I'm going to try and talk to the switch live. So I didn't just make all this up. Here you can see I have root on this switch. I am connected, so I'm going to make a change. Where is the change I want to make? I'm going to say right there. Okay, so this is my, so in the abstract, I thought I would be done with this project a lot sooner and that the app that I put on the thing would be like done and could talk to like Home Assistant and all this stuff. In actuality, just don't check the commit times on the repo. because it kind of came in hot. But this is like the beginning of this project, not the end. I'm not presenting the final form. I'm presenting the start of being able to do being able to put an app in my wall and have it do fun stuff and connect to things. Also, if you buy one of these, probably don't let it connect to the internet. I don't have time to tell you why, but let's just say it's Chinese, it's very cheap, and it calls out to random IPs, and it has a microphone. So I'm gonna switch over from, no pun intended, to that one of the original things that I built that I showed with the ripples, and I'm going to try to run this. I'm on the switch. I need to be on the, let's do debug. It will be faster. I forgot that I was supposed to start this earlier. The reason we're not doing a lot of things live is because it takes forever to deploy things to this. It is a Wi-Fi device. Currently, it is connected to my phone as a hotspot, and my laptop is also connected to my phone. So I was supposed to do this and then talk about stuff so that we could not sit here and watch a 3-minute deploy process. All of Compose UI, Ktor, coroutines is in there. I also have Kotlin serialization to do the JSON stuff. I think it turns into maybe 100 meg binary. Not not nothing. The switch itself, I think I said maybe 150 megs is free space. I had to, in order to actually run the app, I had to delete the built-in app, which is a little scary. I would also say that if you want to do something like this, in the 7 months that I was lazy and did absolutely nothing with this project, the manufacturer of the switch was not lazy, and they were updating a bunch of stuff in their OS. And part of that was getting rid of the backdoor that we use. Some, I don't know what to call them. I would normally call them a crazy person. Very eager hardware hacker found that you can basically crack open the switch, and there's pads that you can solder a serial connection, and then intercept the Linux boot command and change it so that you can restore root access to the device. Which is, so the reason I have this other one is because I accidentally, my very first one, I accidentally allowed it to update, past the original version of the OS, and it was no longer able to be hacked. And so then I went and bought, 4 more, hoping that it was the original version of the OS, which it was. And then you immediately go and you turn off automatic updates. I'm running out of things to say while we wait for this to happen. Hopefully it is actually visible on the screen while it happens. I also have done a terrible job, so I know what we can do while we're waiting. Although it's probably gonna show a bunch of stuff it shouldn't show. New tab. Okay. I forgot to make the repo public, so we'll just do that live. All the forks are already public. They've been public. This repo has all of the work that I've done. Stands up the graphics stack, interacts with skia and Compose UI to set all that up. It also has copies of things on the device. So this is where you don't actually have to have the device for this to build. So there's all the headers that I've done the binary search to figure out the versions. There's all the SO files that I've pulled from the device. And then it also has the built-in UI if you want to reverse engineer that and figure out how the serial port stuff works. That would be fantastic. Let's go here. Doing it live. Make it public. Yes, I know what I'm doing. I probably have to, yes. Okay. Still hasn't deployed. I don't want to talk about this. Sometimes it crashes when it starts up. The Flutter code has like this extra loop where it's like, if this thing didn't work, fall back to this other thing. I'm like, I don't need that. And so it crashes sometimes. Oh, it just won't start up. That's fine. Oh, yeah. What's it complaining about? Oh, you know why? Because again, in my infinite laziness, now I'm gonna have to build. I'm gonna have to build again, and I'm already out of time. If you want to play with this, though, I'd be more than happy to let you play with it after the fact because I'm out of time. So this is the repo. Oh, I gotta approve the 85. Don't steal my identity. 85. Boom, open source. Yeah. So this is the end of the talk, but in reality, it's the beginning. I want to build interesting things with this. I don't want it in every room of my house, but in one room, having the ability to control like music that's playing on speakers or what's playing on the Linux ISOs that are playing on Plex or the Home Assistant lights that are turning off or whatever. So the thing is this is the end of the journey to get to the start of building the actual app. And so hopefully, in the future, you'll see, cool things being built with this. And also, just make an easier device to hack, please, if you're a device manufacturer. I shouldn't have to go through all this. But thank you all for your attention. If you want to, I'll be out somewhere with the switches. Happy to show you what's going on. And don't forget to turn off the lights. Thank you.